Students, in this question, as you can see that there are three coordinates already given to us, and the question says like this, that if a comma 1, that is a coordinate of the first point, then 1 comma minus 1, that is a coordinate of the second point, and then the third point coordinate is 11 comma 4 are collinear. That means these 3 points are lying on a straight line. Collinear means that if 3 points are lying on a straight line, that means these 3 points are called as collinear. Then find the value of a. That is, we have to find out the value of this abscissa, which is represented as a. So because the 3 points are given as collinear, it means that if you are going to take the sum of the distance between the first 2 points and the last 2 points, then that sum will be equal to the distance of the first and the last point. I am repeating, collinear points can be proved if the coordinates of any 3 points are given. Then collinear points can be proved by taking out the distance of first 2 points and then the distance of the last 2 points. And when you are going to add these two distances, that will be equal to the distance between the first and the last point. So the same concept we are going to use for finding out the abscissa of this first point, which is represented by a. So a, which is having the coordinates as a comma 1, b, which is having the coordinates as 1 comma minus 1, and c, which is having the coordinates as 11 comma 4. So the distance between will be again, it's up to our choice. Out of these 2 points, we can take any one point as x1 y1, so the other will be x2 y2. So I'm going to take this point as x1 y1 and this point as x2 and y2. So the formula for distance says under root x2 minus x1 whole square plus y2 minus y1 whole square. So because we have considered this point as x2 and y2 and this point as x1 and y1, so it will be x2 minus x1, that is a minus 1 whole square. Then plus sign y2 minus y1. So y2 is actually 1, then minus sign, then y1 is actually minus 1 whole square. All this we are going to write under the root sign. Then in the next step, below the root sign, it will be a minus 1 whole square plus this will be minus minus plus, so it will be 1 plus 1 whole square. So a minus 1 whole square can be expanded by using the identity of a minus b whole square. So we are going to use that identity and we are going to square this part, and it will give us the result under the root sign as a whole square, which will give us a square, plus 1 whole square, which will give us just 1, and then minus 2 into a into 1, that will give us minus 2a plus 4. So as these two are like terms, on the root sign, it will be the distance of AB as under the root sign a square minus 2a plus 5. In the same way, children, we are going to find out the distance between B and C. Okay, so the B point was given as 1 comma minus 1 and the C point was given as 11 comma 4. Again, for finding out the distance between these 2 points, remember that we can take any one of the point as x1 y1 and the other point as x2 and y2. So I'm considering this point as x1 and y1 and this point as x2 and y2. So you know the formula of distance. Under the root sign, what you are going to write, x2 minus x1 whole square. So x2 is actually 11 and x1 is 1, so it will be 11 minus 1 whole square plus y2 minus y1. So y2 is actually 4, that I'm going to write, then minus sign, and then after that y1, which itself is a negative value, it will be written inside another bracket. So it will be 4 minus 1 whole square. 11 minus 1 whole square can be changed as 10 square under the root sign, plus minus minus is actually plus, so 4 plus 1 will be 5 whole square. Then 10 whole square is 100 plus 5 whole square is 25 under the root sign. Then under the root sign, it can be written as root 125 units. So this is the distance between B and C point. Then for finding out the distance between C and A point, we are going to use again the distance formula, and this time what we are doing, that the A point, which is having the coordinates as the a comma 1, I am considering this point as x2 and y2, and this point C, which is having the coordinates as 11 and 4, it will be x1 minus y1. So as per to the formula, it says under the root sign x2 minus x1. So actually x2 I have taken it as a and x1 I have taken that as 11. So it will be a minus 11 whole square. So that is what I have written, you will see over here, plus y2 minus y1. So y2 is actually 1 over here, okay, and y1 is actually 4 over here. So it will be under the root sign 1 minus 4 whole square. Now as you can see, a minus 11 is actually an expression which can be expanded by using the identity a minus b whole square. So this can be written as under the root sign as a whole square, which will give us a square, then 11 whole square, which will give us plus 121, then minus 2 into a into 11, that will give us minus 22a, plus 1 minus 4 is actually minus 3, so it will be minus 3 square. Then under the root sign it can be written as a square minus 22a plus 121 plus 9, because minus 3 square is plus 9, which will finally give us the value of the distance between C and A point, and that will be under the root sign a square minus 22a plus 130, because 121 plus 9, because they were like terms, so on adding they have got as 130. Now since it was given that the points are collinear, it means that if you are going to take the distance AB and you are going to add it with the distance BC, then it will be equal to the total distance between A and C point. So I have written the distance of AB, that is under root a square minus 2a plus 50 plus 5, then plus BC distance, that is root 125, and then equal to CA distance, that is under root a square minus 22a plus 130. Now what we are going to do, we are going to square up both the sides, that is on the left hand side and on the right hand side. So on squaring up this side, it can be written as under root a square minus 2a plus 5, then plus under root 125 whole square, equal to, on the right hand side it will be under root a square minus 22a plus 130 whole square. Then after that, on the left hand side we are going to use again the identity. This part will be totally considered as a and this part is considered as b, so it will be a plus b whole square. So on squaring up this part, we are going to write as under root a square minus 2a plus 5 whole square, plus on squaring this part we are going to write under root 125 whole square, plus 2 into this quantity into this quantity, which can be written as 2 into under root 125 into under root a square minus 2a plus 15. This entire part is actually 2 into a into b, which is a part of the identity. Then after the equal to sign, because it was given under root a square minus 22a plus 130 whole square, so it will be, the square root sign will be removed and it will be a square minus 22a plus 130. Now on squaring this part, it will give us the value as a square minus 2a plus 5. That means this entire quantity will be free from the root sign, and under root 125 square will give us the value as plus 125, plus 2 into root 125 into root a square minus 2a plus 5 will be written as it is. This is actually the previous term 2 into a into b, so which will be followed as it is, equal to, it will be a square minus 22a plus 130. Now if you are going to bring this a square on the other side, so this a square and this a square will result us as a 0. So that is why I have cancelled this a square with the other square a square, because these are the same terms but on the opposite sides of the equal to sign. Next, as you can see, it will be written as, after cancellation of a square, it will be minus 2a, then plus 130. 5 plus 125 is 130, plus I have copied the same term, 2 into root 125 into root a square minus 2a plus 5, and on the other side it will be equal to minus 22a plus 130. Now in the same manner as I have cancelled a square and a square because they were the same terms but on the opposite sides of the equal to sign, so even on transposing, the sign of this term will get changed and then to the result will be 0. The same thing is going to happen over here. On this side it is 130, on the other side also it is 130, so there are same terms with the same signs, so they can be cancelled because they are on the opposite sides of the equal to sign and they are the same terms. So as you can see, if you are going to shift this 130 on the other side, then to it is going to the same, plus 130 and minus 130 will result as 0. So finally we are left with what? We are left with minus 2a, which I am going to shift it on the other side, okay, and on the left hand side it will be 2 into root 125 into root a square minus 2a plus 5, equal to, because we have shifted this minus 2a on the other side, so this will become minus 22a plus 2a, which will result as minus 20a. So now the equation will become, on the left hand side, as you have seen it in the previous part, it was 2 into root 125 into root a square minus 2a plus 5. This is the same 2 into ab term, which is still going one step further, then equal to minus 20a. Now we are going to bring this 2 in the denominator part so that the equation can be reduced further. So it will be root 125 into under root a square minus 2a plus 5 is equal to, on its cancellation, will give us the result as minus 10a. So again we are going to use the same method of squaring both the sides. This time I am going to square up this entire part. Root 125 into under root a square minus 2a plus 5 whole square is equal to, on the other side we are going to square minus 10a whole square. So this side root sign will be removed and this term can be written as 125 into this side also root sign will be removed and it can be written as a square minus 2a plus 5 equal to 100a square. Now again what I'm going to do, because this 125 is connected with a square minus 2a plus 5, I'm going to bring it on the other side of the equation in the denominator part. So now the equation will become a square minus 2a plus 5 equal to 100 into a square upon 125. So 100 can be cancelled by 25 4 times and 125 can be also cancelled by 25 as 5 times. Then on this side the equation, as you can see, it can be written as a square minus 2a plus 5 is equal to 4 upon 5 a square. Now on bringing this term on the other side of the equal to sign, it will be a square minus 4 upon 5 a square minus 2a plus 5 equal to 0, because I have brought this term on transposing on the other side. Now if you see, there are 4 terms and if you are going to take out the LCM, it will be just 5. Okay, so 5 directly will be multiplied with a square, it will be 5a square, then 5 is divisible in the table of 5 one time, so 1 into 4a square will be 4a square, and because these two terms are having the minus sign in between, so I'm going to copy that minus sign. Then again 5 will be directly multiplied to 2a and it can be written as 10a, and then between these terms there was a minus sign, I've copied that minus sign. Then again 5 will be multiplied with the last constant, that is with 5, that will give us a value as 25, and because in between these two terms there was a plus sign, so I'm going to keep the plus sign equal to 0. Now on cross multiplying and bringing this 5 on this side, it will be also 0. So now the equation will become, that is 5a square minus 4a square will give us a square minus 10a plus 25 equal to 0. Again this is a quadratic equation that is formed, which we are going to solve it by factorization. So we are going to split the middle term, which is given as minus 10a, into minus 5a and minus 5a. So now the equation form will be a square minus 5a plus 125 equal to 0. The first two terms are going to form the first group, from which we can take a common. So from the first term, if you are going to take a common, a will be left. From the second term, if you are going to take a common, minus 5 will be left. Then those next two terms which are going to form the second group, from these two terms I'm going to take minus 5 common. So on taking minus 5 common from the first term, we will be left with a, and from the second term, if you are going to take minus 5 common, then minus 5 will be left equal to 0. Children, remember that whenever you are factorizing a quadratic equation to find out the factors, always remember when you are splitting the middle term and taking out the common. So remember, whatever is left inside the bracket after taking out the common part in the first group, the same should be left inside the bracket when the any term is taken out common from the second group. So now we are left with a into a minus 5 into a minus 5 after taking out common between them. Now from these two terms, again a minus 5 is common, so we are left with just a and then minus 5 equal to 0. And then by applying the zero product rule, a minus 5 equal to 0, so therefore the value of a will come out to be 5, whether you equate this with 0 or equate this factor with 0. So the value of a will be coming out to be 5, which is the final answer. So we have got the abscissa of that unknown point as 5.